Hello, welcome to our Spring 2022 Planter Clinic and Tune-Up. My name is Clayton Stuffelbeam. I'm a PFR agronomist with Beck's Hybrids. I'm located out of Central Illinois. The planter pass, in my opinion, is the most important pass you're going to make all season. So it's really important to focus on maintenance, and that's where I'm going to start. Towards the end of the presentation, we'll start to get into some of our planter-based yield data from our research locations throughout our marketing area. I like to start with this slide. This is a random quote that I found online, but it holds true. It's pretty extreme, but I believe it holds very true. The planter is a one piece of equipment that you can put away in perfect running order. And then when you pull it out the next year for the next planting season, it's a complete piece of junk. Well, that's pretty extreme, guys, but at the end of the day, what happens is we go and plant our crop, and then we put our planter away early June, late May, whatever time it is, the season's over with, and then it sits in the shed until December, January, February, early March. And we pull that out, and all that time has elapsed, and you forget what kind of shape that planter was in when you put it up in the shed. All too often, I've come across planters, we get really close to planting season, and they're way out of condition. So we need to spend the time on maintenance. So where I like to start is maintenance before upgrades. I want to spend those maintenance dollars first to make sure my foundation's in great shape before I spend the money on upgrades. Just like a kitchen in your house. You're not going to put a brand new kitchen in your house if your foundation's junk. So make sure the planter's got good bones. So where I like to start is a parallel linkage. So when we start looking at parallel linkages, all I need to do here is grab the back of a row unit. And we're going to move it up and down and side to side. So this row unit doesn't have much side to side movement. Most of the reason why is because the older John Deere Downforce systems have a link bar that links the top two parallel arms together. So that limits the side to side movement. But if I have movement of up to 1/2 inch of play at the tail of that planter, I need to start thinking about replacing parts. Because at the end of the day, it's really important when this seed tube and the seed's coming off the meter to keep that trajectory of that seed as consistent as possible. Even in a smooth seed bed, if I introduce any sort of chatter to that row unit, I'm going to change, number one, spacing and or depth. So with a seed tube, I want to make sure it's staying at the fixed position in the row unit at all times. If I'm introducing that chatter, I'm moving this. And when I move that, I change the pathway for that seed to travel down and to come out at an even spacing for each individual seed. So I can help keep that from being a big issue with my planter by maintaining my parallel arms. So where do I start? If I've got worn arms, what's the best case scenario for me to go through this? So I'm going to pick on John Deere here a little bit. The John Deere parallel arms have been used, the same exact part number, have been used since the John Deere 7200 MaxiMerge 2s. So that's roughly a little bit over 30 years. Same part number today with their MaxiMerge 5 row units. So if I come back and I look at a MaxiMerge 5, we got one right here, brand new row unit, never been used. And I go to pull up on it, and it's got movement. Okay, so what to be thinking about those things. It's not that planter row unit there, I'm not concerned about throwing parts at it today. But if we start getting worse than that or seeing wear, I've got to think about what parts to replace. The unfortunate side about a John Deere planter and a earlier Kinsey planter, the parallel arms are softer than the bushings, which means if I think I can get by with replacing just bushings and bolts, you're probably not going to be able to pull that off because the arms are softer than the bushings. All too often I've seen guys replace bushings and bolts and get done, and they didn't fix the problem at hand. They did not fix any of the sloppiness that was in that row unit, and they did not take that out. For a Kinsey row unit, for a 2600 through a 3600 row unit, their parallel arms are punched. Similar to Deere, they're softer than the bushings themselves, but being punched means when they punch that hole, one side of that arm is wider in diameter than the other side of the arm. So you're going to wear those arms out unevenly, and they're going to wear fairly quick. Their bolts on a Kinsey row unit are also threaded with fine threads from the bolt head clear down to the end of the bolt. They don't have a smooth shank for that bushing to ride on. So as it wears them threads out pretty quickly. Sometimes with a Kinsey row unit, we can get by with just replacing bolts and bushings if the arms aren't worn. But I always want to look at one row case scenario when I start to throw parts at a planter. If it fixes the problem at hand, I can do the whole planter. When we start looking at parts for a John Deere planter, bushings and bolts are going to cost $45 a row. So for a 16 row planter, it's $720. The problem is that won't fix the problem at hand. Very unlikely that you will get by with replacing just bushings and bolts. Now bushings and bolts plus new 16-inch factory standard length arms, that's $200 a row. So for a 16 row planter, $3,200. That'll fix the problem, but you'll still have to be in the rotation of rotating arms out every so many seasons because the bushings wear into the arms. Now, Precision Planter Solutions is a company that makes a flange kit. Their flange kit is where we ream out the parallel arms and we ream out the front of the row unit right here, and then we insert this bushing kit on this other arm. We also ream out the W plate on the toolbar. That tightens the whole system up very nicely. That kit's $127 a row, so for a 16 row planter, we're looking at a little over $2,000. That kit, the flange, is twice as hard as the inner bushing, so as it wears, we're going to wear the inner bushing out and not the flange. We will never have to replace arms again, and I can use my factory arms. The problem is, it's a fairly labor-intensive kit to install. It takes quite a bit of time and resources to make that happen. So they do offer a pre-installed kit, and what that means is they're going to ship you brand new arms where the holes are the correct size for their flange bushings, and all you have to do is press them in. You still have to ream out the front of your row unit and the W plate on the toolbar. That kit is $265 a row, so for a 16 row planter, we're looking at a little over $4,000. Both of those kits can be purchased from SI Distributing. Now the other kit is the Solid Rock Ag Swap Program kit. That is where Solid Rock Ag, they're based out of Indiana, they take parallel arms, used arms, and they mill them out and then install a bushing into that arm. That kit is $145 a row, so for a 16 row planter, little over $2,000 will get you the kit, and they will refund you for the core when you ship your arms back to them. The third kit is from GBGI. That's a kit similar to Solid Rock Ag. They are new arms, however, and the bushings are installed in their arms, and they work similar to where they have a bushing inside a bushing. All three of these solutions get you out of the process of rotating arms every couple seasons. So here's a Kinsey 4905 row unit. Their arms have a bushing that's machined into the arm itself. So as the inner bushing wears, I don't have to replace the arms anymore. I can knock this bushing out, replace this bushing and this bushing, and then we'll be back to new again. They also have a kit, a factory kit for their Kinsey 3000 series units that is built just that way. So they know there's a problem and they're working on fixing that problem. At the end of the day, it's key to keep your parallel arms and your bushings in good shape for continued planter success. So from the parallel arms, where I like to go is the disc openers. So we're going to talk about disc opener contact, which is really important. We're going to talk a few other subjects to get us to the contact. So what we see on the screen here is a Shoop 3.2 millimeter blade, and we're going to check the run out or the wobble. I like to call it the run out. And all we do is we take a blade, and I made a jig a while back. And I'm going to spin that opener. And all I'm looking at is the horizontal movement when it's positioned on a row unit of that run out. And that's key. Now there's some people out there saying I need to have an opener with a run out of 3/1000 of an inch or less. Well, 3/1000 of an inch is 3 business cards, okay? If we're trying to target an opener that's at 3/1000 of an inch, you're going to go through pallets of openers trying to source enough for your corn planter. That takes a lot of time, and it's also going to pull some openers off the marketplace where farmers might need them for this season. Supply shortages are real. I don't think we need to go down that road. It's a good idea to maybe run out a couple of your openers just to see how good they are. And if they're pretty poor, I'd think about going to a different brand. But the chances are they're going to be good enough, and I can compensate for that. So on the screen here, you'll see that Shoop opener at the standard 3.2 millimeter blade. It's got a run out of about 0.045, which is 45/100ths. So 3/1000ths, again, is 3 business cards. It's going to be very hard to do that. The other openers we've looked at is the Ingersoll and the Wear Parts heavy duty blades. Their run out is less. It's on the chart right here. The Ingersoll sitting at 2/100ths. The Wear Parts is sitting a little over 2/100ths. And then the STP disc opener from Prescription Tillage Technology, it sits at right at 100th. It's the best, but it's also the thickest blade at 4.3 millimeter. So I do want to check a few openers. You don't have to run all of your openers. How we're going to compensate for that is I'm going to take my business cards and we're going to come in from the top and we're going to come in from the bottom until I stop, and I'm going to measure the distance in between both of those openers. Now the key is I like to use a micrometer or a caliper to measure that distance. The key is not to do it one time around the openers. I need to do that 3 or 4 times. That will compensate for the run out of each individual opener. The key is when I set that contact, every planter manufacturer is going to be different. A heavy duty blade needs to be shimmed differently than a standard blade. A standard blade takes more contact than a heavy duty blade. When I'm setting that contact, a Kinsey row unit is a 1/2 inch to 1.5 inches worth of contact. A John Deere Maxi-Merge 5 is 1.5 inches to 2.5 inches of contact. On the average, around that blade, I want to try to land somewhere right in the middle. 1.5 inches to 2.5 inches of contact, I want to land at 2. That's where I want to try to land, average around that opener. I do not want to land at the lower part of that contact on any side of that opener. Because if I'm at the lowest part of that contact as it wears throughout the season, we'll start to lose contact, which will create a W in the seed trench. And if I make a W in that seed trench, we're going to have problems with seedling emergence because I'll have air underneath that seed. If I'm at the upper end of that range of contact, I'll put tremendous amount of pressure on the hub of the opener. If I'm putting pressure here, my hub will not outlast the opener itself. We'll have issues. I don't want to get into that area, into that problem. So let's make sure we're shimming them openers right in the middle of that contact. Okay, so like I said, for a John Deere row unit, we want 1.5 inches to 2.5 inches of contact. So I want to try to land around 2 inches for my range. The first check here, I'm sitting at 1.88. And then we're going to rotate that opener a little bit. And we're going to do it again. It looks like I'm a little bit closer together this time around. 1.83. You can also mark these with a permanent marker so you know where you've been, so you don't encounter the same spot twice. 1.75. That was try number 3, and then here's number 4 right here, which we found a spot where we get to the low range of our contact. So at this point, we got to do some shimming, or I've got an opener that's got really bad run out. So if that's the case, I'm gonna go ahead and we're gonna put it on the table and we're gonna check this opener out and see why I'm losing contact here. Really, really important to check this out because at this contact point, we are going to have a W in our trench. So make sure we take that time to check every single opener on our planters every single year, and we're back at 1.9. So the run out on this opener, I would say is fairly bad. And we're probably gonna put it in the scrap pile and get a new one. Something else I feel is really important when looking at openers is to set it up on a jig again. And we'll set something close. If you can have it fixed, that's more ideal. And I want to check that bearing placement. If that hub and bearing is not centered well in that opener, I'm going to get rid of that opener. Because at that case is where we're going to change planting depth. I don't want to change planting depth. I want very consistent planting depth. Now, when do I replace an opener? So the old rule of thumb is a standard opener is 15 inches in diameter when they're new. This John Deere opener here measures 14 7/8. Okay. So with the old way to change an opener at 14.5 inches, this opener is considered a good opener. However, when we start looking closer, we look at the bevel. And the bevel is almost gone. So when an opener wears, it's going to wear in diameter and it's going to wear in thickness. I get another opener here and we start comparing bevels side by side. Even though the old John Deere opener measures in spec, I'm going to change that opener. It's going to do a poor job of cutting, and as it wears in thickness, it's going to flex easier. When it flexes easier, it's going to make my seed trench narrower at the bottom and prevent that seed from going clear to the bottom of that seed trench. So as a rule of thumb, I want to measure a brand new opener for the original bevel measurement. For the Ingersoll, Shoop, and the Wear Parts openers that I have on the table with me today, they all measure at 10.38 millimeters. So when they get at 5 millimeter or less, I want to change those openers out. When I change openers out, I want to make sure we change our guards. And the guard is there for two reasons. Number one is to keep my seed tube protected. Number two is to keep them openers from flexing too much and making my seed trench narrow. So a good measurement to know when to replace a guard is 5/8 of an inch to 3/4 of an inch. Right in that range somewhere will cover most planter manufacturers to replace these guards. I just want to make sure as I replace my openers, we're going to replace guards. That'll prevent them openers from flexing too much. And then we'll cause seed tube damage. So the left side of this opener is worn pretty hard. The right side not quite as much, but you'll see that dog ear, that flap is right in the middle of that seed tube. As the seed encounters that flap, it's going to change the spacing. So it's going to cause issues. The other thing I notice about this guard in particular, it's worn hard on one side. So when the farmer that had this guard shimmed his openers, he pulled shims out of one side and left them on the other. So when you shim your openers, I want to make sure I balance my shims out. So I should have the same number of shims on each side of that row unit. Guards are fairly inexpensive, so let's make sure we make that investment to change those guards. Now for a Case IH planter, we'll talk about that pretty quick here. They have a leading opener and a following opener. So for their openers, we need to have contact of an eighth of an inch or less. So a little bit of a gap to an eighth of an inch of contact is where they need to be. Their system is completely different. They have a firming point and a shoe. To know those measures, go to your Case IH dealership. They have some tools to help you measure each of those components to make sure they're within spec. At the end of the day, I'm trying to firm a very good seed trench for my seed to get clear down to the bottom then have the highest chance possible for even seedling emergence. All right, so the next part, we go from disc openers, we're going to come into gauge wheels. The relationship between the disc opener and the gauge wheel is really important. So I want to make sure I get that relationship right. I'm going to pick on the Kinsey row unit right here. As far as setting that, I want it to make good contact with the opener. Not too much, not too little, right in the range. So what I'll do is I'm going to pick up on that gauge wheel, and then we're going to drop it. And as it comes down, it should spin. If it doesn't spin, I don't have enough contact. If it stays up in the air and it takes some force to push it down, I've got way too much contact. The key to this is, with a little bit of contact, that prevents dry soil from entering my seed trench out of the inside of that gauge wheel. With too much contact, it can't get out, or if I get mud in there, if I have to plant through a mud hole, I know we shouldn't do that, but in the case you do, mud cannot get out of that. So if it's too tight, mud or soil can't get out and escape that gauge wheel. That's where Mudsmith gauge wheels, spoked gauge wheels come into play, so that mud or soil can get out of that opener, but not end up in the seed trench on top of your seed. Now, if that relationship is too loose, I don't have enough contact, that dry soil that rides on the inside of that gauge wheel is going to end up right in your seed trench. We don't want dry soil on top of our seed. That's going to inhibit good, quick emergence. So let's make sure we get that adjustment right. On a row unit that's got some wear, like the John Deere unit here, I've got some play in this bushing. I won't be able to keep that relationship. That adjustment is key. So I want to add some parts and make it good as new again. So one of those kits is from Copperhead Ag. It's the old RK gauge wheel kit. They bought RK systems out a couple years ago. That's where we side load this bushing right here. And it takes the load off the pin. You adjust them a little bit different. Same relationship with the opener, but it's going to keep that relationship nice and tight, and I can get that planter new again. For a John Deere, a MaxEmerge Pro through MaxEmerge 5, like the row unit we have right here, that is a screw adjust lateral movement instead of using shims. Over time, that gauge wheel arm will wear into the threads of that adjustment bushing, and it'll wear out fairly quick. So as that wears, it'll get sloppy pretty quickly, and we'll have to continue to replace arms and or inner bushings. So a kit from Coyote Machining, they will bore your arms out and insert bearings into your arms, and that then we'll have to shim those arms instead of using that threaded bushing to move that arm in and out, but that will solve the issue of that wearing out prematurely. So if you're okay with replacing arms every couple of years and you like the adjustment, I'd continue with that path on a John Deere row unit. If you're getting tired of those arms wearing out prematurely, I would look into either the RK or the Coyote Machining kit to help get that planter back to new again. Now the next part, I think, is the most important part that we can cover at a planter clinic, and that's indexing your row unit. This is key. So I learned this a few years ago, unfortunately, firsthand experience. We planted some research plots at our Central Illinois PFR location, our first round of planting. A couple days went by, corn started to come up, and we started to look at the planter passes, and we'd have 2 of the 4 rows were coming up late. Even though that planter was set at the same depth, we had late emergence. So what caused that? So when a planter depth system works, or how it works, so on a John Deere row unit, I've got a equalizer, this is what I like to call it, or a mustache, that rides on the gauge wheel arms. Where my thumbs are right here, you'll see the divots. There's a lot of pressure there, and it's going to wear every single row differently. The mustache that's inside that row that's keeping that depth is also going to wear differently from row to row. On a bigger planter, your outside rows are going to wear quicker than your center rows. So that's going to change your planting depth. Okay, so for a John Deere Maximerge 5-row unit, here's my depth equalizer or mustache. As I raise that gauge wheel up, it's going to make contact with that. It'll wear into the gauge wheel arm itself and the mustache. Every row is going to be different. That's why it's so important to index the planter and get that planter zeroed out before you get to the field. Here's the equalizer on a Case IH 2000 series row unit. As I pull the gauge wheel up, it'll make contact up there. So the same goes with indexing, just getting everything zeroed out and equal and making sure these parts aren't too worn. Lindsay 4905 row unit, my depth mustache is right here and it rides inside the gauge wheel arm. As we get the depth, it's going to pull tension on that mustache and it's going to slowly wear out the inside of this arm. So if I have my gauge wheels off, I want to ensure that that's not to the point where it's going to wear clear through that arm. This is a white 8000 series row unit. As I pull up on that gauge wheel, here is my depth mechanism. And then it goes through the holes on both gauge wheels so it'll wear the holes. As it slowly wears, and you pull up there and find depth, it'll wear on the front side of that. So just want to make sure everything's in nice, good working manner and in good shape. So how do we index a planter? So the old way I used to do it is pretty time consuming and took a lot of work. I lift that planter up and we put blocks underneath the gauge wheels and we let that planter down and I measure from the floor to the bottom of that opener, considering all the depth was the same on the planter. And we come across rows that were different. As they're different, we would change our T-handles to get it right. So another way to do this is this contraption. I found a picture of this from Iowa State University. I want to give credit to them for making this job easier. So what we're going to do here is we're going to take this contraption that you can easily make at home, and we're going to go to this white planter here, and we're going to actually index this planter and get it consistent. So let's start that process now. So what I've done here is I've taken some 2x4s and we've added some tape measure on the inside of what I'm going to call a window here. I can see that opener through that window and I can get a measurement from row to row. We're going to carry it around on a floor jack. We're going to jack each row up individually, and as we jack it up, our goal is to get the planter the same consistently across the whole toolbar. We're not setting our planting depth in the shop. We're going to do that part in the field. We're just getting all rows equal. We don't have to throw parts at the planter. All we got to do is change our depth handle. So for a John Deere, a Kinsey, or a Case, we're going to move that stop, and then we're going to mark each handle where it needs to be in relation to the next row. On this white planter, we're just going to turn the adjustment handle and we're going to get all rows equal. No marking needed to be done there. As I change my depth in the field, we're going to move each row the same number of turns at the end of the day. The goal is to get the planter equal in the shop. So we're going to start row number 1 here as our baseline. Where do we sit?
We're sitting at 2.5 right now.
2.5 inches right now. So we're going to go ahead and move on to the back rows. We're going to go row to row here and check this out.
Go back a little bit. Okay.
We're going to jack it up to where we take pressure off the row. Okay, where we at?
We're sitting at about 2 1/4 on that one.
So we need to go deeper,
Yep.
1/4 inch.
Yep.
So that is how many turns in this planter?
1.
1 turn. Now we're going to check it.
2 1/2.
Okay. Go to the next row.
Right there.
Like it?
Yep. About 2 1/4 on that one as well.
So we need to deepen it up. Half, right?
Yep.
Half or one.
Right on the money.
Okay. Like it?
Yep. It's like we're about 2 3/4 on that one. So shallow up.
I'll tilt it back here a little bit.
Looks good. We're sitting about 3 inches on that one.
It's 3 inches, so we gotta go way shallow. Which is 2 turns and a half.
We need to go just a little bit deeper on that one, actually. Take that little half turn back out.
Half turn?
Yep.
Okay.
There we go.
Okay, one more.
That one seems to be on the money.
Should have been. Okay. So thanks, Aaron.
Hey, no problem.
That's how we're going to index our planter. Aaron's done it the hard way of setting that planter down on blocks and then picking it back up again. A lot of getting in and out of the tractor. We'd have a couple hours doing this 6-row planter, and we've got less than 5 minutes doing it. All rows are equal today. We go out to the field with full confidence we're going to be in good shape. This is a step that's easy to do. Make one of those contraptions in your shop and then utilize it, make some for your friends and your neighbors. This is the most important part of planter maintenance. You can also make a device like what's on the screen here, as complicated as you want, to help you index your planter easier. This device has a spring-loaded indicator on the back side of that steel. As you set the planter down on that steel, it moves that indicator to a measurement that's on the back side of that steel, and then you just go from row to row and do it that way. At the end of the day, we want to place all of our rows at the same depth out in the field, so each row has the same chance of good, consistent emergence. So from the gauge wheels, we'll start moving into other maintenance. We're going to talk about meters very quickly here. If you're running finger meters, I recommend running them on a meter stand at least every other season. If we're planting a considerable amount of acres, I'm going to say 1,000 acres of corn a year, I want to run that meter every year. We want to look at the belts, the brushes, and the backing plates and make sure everything's in good shape. Most newer monitors are going to catch any problems that a meter might have. If you're running an older, just for an example, a Kinsey KPM or a John Deere CompuTrack, they're not going to catch those problems. So I recommend running them on a stand. We start looking at vacuum meters. The parts are different. So for a vacuum meter, this is a precision planting V-set. One half, I've got a singulator and a brush. The other half, I've got a seal, a knockout wheel, a few shims, and then my disc. The first thing to wear is going to be the seal. So I want to inspect that seal, fold it over, make sure there's no worn cracks or frills in that seal. If there is, we're going to pull it out. It comes out nice and easy. You just start pulling on it, it'll come right out. And I want to replace those seals. That'll help keep consistent vacuum pressure from row to row. The other thing is the brush. The brush will go next. If the brush bristles are folded over, pull those out and replace those brushes. Pretty easy to do. Like I said, most newer monitors, we're going to find those issues pretty quickly. We don't have to run them on a stand. Seed tubes, we've already taken a look at that seed tube. If I have dog ears or cracks in that seed tube at the bottom of that tube, toss them, get new tubes. Speed tubes. I want to inspect the tubes. Each system is going to be a little bit different. We'll cover them in depth later on in a different chapter. But for precision planting speed tube, for example, I want to take these finger wheels out. Every season, I want to inspect behind them, pull any mud or soil that's been packed in behind them because it will rip fingers off. Precision recommends replacing these every year. I also want to pull the belt out and we leave the tension off of that belt and hang it on a nail or put it in a box throughout the winter so we get the tension off. I also want to fold the cleats over and I want to inspect the base of those cleats. If I have cracks in the base of those cleats, let's replace those. Okay, let's get them belts replaced before we have any issues at planting time. Overall, I want to inspect the case as well, make sure it's in good shape. I have had issues wearing into those in the past. So let's make sure we do our due diligence with speed tubes and seed tubes. Closing wheels. I want to follow the manufacturer's specs in their installation manual for the lateral adjustment for the closing wheels. For instance, a Shaft-Vert Mohawk is 2 to 2.5 inches at the base of the spike, okay? So I want to make sure that's right. That's how we've tested the wheels in our research. As I go deeper, I want to widen that out to the wider part of that range. That's how our research has been done. So we've set up closing wheel trials. We've set them at the manufacturer's specs. Seed firmers. If you're running a seed firmer, most scenarios, most conditions, I'm going to recommend running a firmer. This is a Keaton quick change firmer. I'm going to set the planter on a ground. Somehow I'm going to hook a fish scale to this seed firmer. Whether it's a string or whatever, we're going to hook onto the back of it. 20 ounces of pull gets it off the ground. If it takes less than 20, it's time to replace these firmers. They're not doing the job that they are intended to do. A job of the firmer is to get the seed to the bottom of that trench. Ground engaging components, shaft alignment is critical. I've had a few instances in my career where I had either a shaft collar was loose or it wasn't aligned correctly. And if they're not aligned correctly or a collar's loose, that shaft might move and cause a clutch to go in a bind and not turn on and off properly. It's hard to see those areas and pinpoint those problems, but it's time well spent to look at. I want to check all bushings and tensioners. I want to oil my chains before I put that planter up after planting season, and then make sure everything moves nice and smoothly before planting season starts this upcoming season. Bulk delivery systems. I want to check the seal at the lid, make sure it's in good shape so I can keep my good bulk pressure. I want to check that manifold before I turn that bulk delivery system on. That way, if there's anything inside that manifold, I don't push it out to all of my rows and get inside of my meters. General maintenance, check your vacuum. I want to check my vacuum, especially this year coming into 2022 with a product supply shortage. If my vacuum seals out, it's anyone's guess when I could have one in my hands to fix it. So it's a couple weeks before planting season right now. Let's turn on that vacuum in the shop and make sure it's going to function correctly. For a PTO pump that runs a vacuum or a downforce system, I'd like to change that hydraulic oil at least every other season. The reservoirs aren't huge on those systems, and that hydraulic oil does get pretty hot. Tire PSI. If you're setting your tire PSI to what's on the side of the tire, you've got too much PSI in those tires. I want to consult my owner's manual for the planter, look for the tires that are on that planter, and set them for the manual. That'll help me keep my planter level in the field. Toolbar, I want to check my hinges, pins, and welds, especially when I start getting into high-speed planting. Otherwise, I might cause some extreme damage to my overall system. That concludes our planter maintenance portion of this presentation. We're going to move on to some in-field setup and scenarios for this next chapter. So our planter's in great shape. We've done the due diligence in the shop. We've got it to where it needs to be. Now let's get out to the field. Day one, what's going to be your problem? Unfortunately, it's probably going to be electronics or monitors. So before going to the field, here's a checklist that I've come up with that you make sure you do before you get to that first field. I want to update all software. I know that's a pain. I know updates come out way too frequently, but we need to do that because if you have an issue in the field, the tech support guy on the other side of the phone is going to be running the newest version of software. He's probably not going to be running 2-3 versions back like you might have. So let's make sure we get that updated. Connect all technology. In my case, on my personal farm, I've got an ag leader monitor controlling my planter, and I've got a John Deere Green Star running my auto steer and my speed. The ag leader monitor needs the speed off that Green Star monitor. They have to talk. I want to make sure I get my baud rate and all my hertz settings to where they need to be. If I'm a little bit off, I can cause that planter to prematurely shut down throughout a planter pass and leave intermittent gaps. Unfortunately, I know this from experience, so if you don't know those values, make sure you call your planter technology rep to get them off of them. Clear out all of last year's coverage maps. That'll ensure your planter is going to work as you pull into the field when you have swath control. Keep all field names consistent. So as an example, my dad and I have a hard time with this. On our farm, sometimes I run the big planter or the small planter. And sometimes I'll combine and he will combine. We've farmed the same ground for many years on our farm, but neither one of us name fields consistently. And that becomes a problem when we start to analyze our data. As we move forward into the technology and precision ag space, it's really important to analyze data and grow in our operations. Having field names consistent will make that job much, much easier for you and your advisor. It'll save days throughout the winter of having to find the field maps that you're intending to find. So make sure that's consistent. If you have to make an Excel file and tape it to the cab of the tractor, do so. Upload new prescriptions and review them. If you can, a couple days before that first day out in the field, let's take a tractor with the monitor in it to the field or a side-by-side, and let's make sure that prescription is going to work. Because if you do not do this step and you go directly to the field intending to plant that day and that prescription doesn't work, I'd make a bet with you right now that you're not going back to the office to fix that prescription. You're going to plant. And all the legwork you've done with you and your trusted advisors has been a waste of time. Your plan and your intended goal has gone out the window. Just make sure we spend that time. When I'm in the field, the first step I'm going to take is I'm going to level that planter. So that means leveling it from front to back. I want to make sure my parallel arms are level. I also want to level it side to side. If my planter is not level side to side, I might have an end row that's running deeper or shallower than the rest of the rows. So we got to level that planter both directions. Toolbar height, I want to get my toolbar height to where it makes my parallel arms level. If I'm high or low, I can cause that planter to hit the row unit stops and run shallow or deep. What you see on the screen here is a picture of a planter. The no-till coulter is running deep. It's running below the seed openers. I never want to be in that case. That can cause wet, moist soil to come up to the surface and then get into my gauge wheels and pack my gauge wheels plumb full. So I want to make sure we've got those set right, and planter's level will make that job easier. Also, if I'm pitched down, nose down, I'm going to have a lack of pressure on my closing wheel tail, and I'm going to have instances where my seed spacing is erratic. So when I'm level, I solve all those problems with one fair sweep of the paintbrush. We get all those problems fixed. I want to check my depth on multiple rows. So I've already done the job of indexing that planter. Everything should be consistent, but as one final check, that first field, let's dig every single row and make sure. Downforce. This is key. So I want to check and make sure my downforce is correct. And how do I do that? There's two ways that I think of. Pull forward in planting position. I'm going to get into a scenario that mimics the whole field as far as conditions. I'm going to get out of the tractor cab. I'm going to go back And I'm gonna grab that gauge wheel. In planting position, if I can barely spin that gauge wheel, I'm probably pretty close. If I can't spin it, I've got too much downforce. If it spins easily, not enough. Another way to check your downforce, I kind of prefer this method better, is I'm going to take a tie down strap and let's ratchet that closing wheel up. And that'll present me with a clean furrow behind this row unit that I can inspect, get out of the tractor cab, take a seed finder or a knife, and I want to start to poke and peel where the gauge wheels have ridden, and then peel on the inside of that seed trench. If that trench is already collapsed, by the time I get out of the tractor cab and get to that trench, I don't have enough downforce. If I can't peel that trench apart, or if I can't get my seed finder to go into where my gauge wheels have ridden, I've got way too much downforce. I want somewhere in between. I want a good defined seed trench and furrow. I do want to see my gauge wheels where the tracks, I want to see them fairly pronounced, but not too much. There is a line here. I want to make sure I get there, and I want to make sure I check this multiple places throughout the planter pass. Next, we're going to look at closing wheel adjustment and performance. A good way to do this, what you see on the screen here, if I was looking at the surface where that row just planted, I'm probably in good shape from the surface. We start to dig and inspect a little bit further. Let's take a spatula or a paint scraper and let's set it right here behind the row, and then take a knife and dig away from it. That'll show you a profile of that seed trench. If I can find a seed doing it that way, and if I find air around that seed, something's got to change. Either I don't have the right wheel, or I don't have the right adjustment or pressure setting. So let's make sure we get that right. What you see on the surface is not always going to be ideal. I also want to make sure that lateral adjustment's right. If my bushings on my tail are worn, I'll never keep that adjustment. So one more part of maintenance there, make sure we look at them bushings, keep them in good shape. If I've got spike closing wheels, I'm riding hard one direction, I'll get that spike in the seed trench. Then I'm going to move seed. So make sure we spend the time. I like to personally do it in the field. Ratchet your closing wheels up, all of them, pull forward, drop them back down in your seed trench and see where they land. Let's get them line perfect. Row cleaners. Row cleaners do a lot of jobs. I'm a big fan of row cleaners. I think every single planter should have them. In most cases, no-till and strip-till. I want them spinning 90 to 100% of the time, moving residue and clods. In strip-till, just taking the top portion of that berm off from a fall strip-till standpoint to make a good smooth area for my gauge wheels to run. That's the goal. In conventional tillage, I want them spinning 50 to 60% of the time. So not all the time. They're spinning all the time in conventional. What they're going to do, they're going to dig a trench. If I dig a trench, I'm going to create a zone for water to sit and water to run. So make sure we spend the time to get them adjusted properly. If you have row cleaners already on your planter, chances are you've got a good portion of that investment already made to go to air adjust row cleaners. It's hard for me to put an ROI, return on investment, on that number, but it's an investment I feel that you were glad you made by going to air adjust row cleaners. I'm a guy that if I have non-air adjust row cleaners, I give up adjusting them. And from an adjustment standpoint, it's really critical to get them closing wheels set to where they need to be set. Check your clutches and your electric shutoffs when you come in and out of your headlands. Let's make sure that's right, because if you don't, you're going to have gaps at your headlands. Another good way to do that again, strap your closing wheels up, plant in and out of your headlands at planting speed, and then we can go out there and look at individual seeds, where it turned off and turned on. Last year, I was testing a planter. We made a swath halfway through the field and I planted through it, a speed that I thought we would turn around at. And we got it set pretty good. Then I go to do some high speed trials and I pull back on my IVT stick and my tractor and I change my speed too close to that headlands and leave a gap. So make sure we keep everything consistent as we plant. Check seed spacing, let's dig, and let's check our spacing in our population to make sure it's right. That'll help ensure our monitor is correct as well. So that kind of wraps up our in-field setup and management. Now we're ready to plant. The next chapter, we'll get into our planter-based PFR data. Okay, our planter is good shape. Now our maintenance dollars have been spent. My foundation's in excellent shape. Now we can start talking about attachments and the data that goes along to those attachments. So we've done a number of studies over a number of years, multiple locations. We'll get into that right now. We'll start with what is PFR proven. PFR proven is a product or a practice that we have tested over multiple seasons at multiple locations. That product or practice must provide a yield gain every single year and a positive return on investment. So if you see PFR proven show up in the slides in this presentation, that's how it got there, okay? We'll start right off with closing wheels here. Which type? Poly or cast? So I've got a poly and a cast version of the Yetter twisters right here. Whichever you pick is going to depend on your tillage scenario and your condition, your soil conditions, and what speed you're going to plant. So advantages of aftermarket closing wheels. At the end of the day, closing wheels have multiple jobs to do. Number one, first and foremost, they've got to close the trench. So a solid rubber closing wheel can do that. They also need to shatter sidewall compaction. A solid rubber closing wheel struggles doing that. They work on compaction. They do not eliminate compaction. We also need to eliminate air pockets. A solid rubber closing wheel can do that, but they also struggle. So number four, at the end of the day, we're trying to provide good seed to soil contact by doing all those jobs to create better, more consistent seedling germination and emergence. A solid rubber closing wheel is going to struggle on almost every single one of those jobs. So we need to be thinking about other closing wheels in the market if we're still using solid rubbers. I'll bet you that if you put different closing wheels on your planter, you will have a better return on investment. So let's get into those wheels. 3-year multi-location data across multiple different tillage scenarios. Yetter Poly Twister does do the best in our trials, but that's our trials. That's not saying that's going to do the best on your farm. So here's my recommendation. If you're still using solid rubbers and you're looking for something new, let's buy a few rows of something else. I recommend trying 1 or 2 rows of 2 or 3 different closing wheel types. And let's try them out. In our testing, the Yetter Poly Twisters, in fact, all the wheels we have tested, have been tested as a pair. Here's the reason. The older spiked wheels were thin and they didn't have this firming base. When I have a spike wheel that has this base, I'm combining the action of a spiked wheel and a solid rubber closing wheel with that base. So I get firming action out of the base and I get the aggressiveness of a spike to help eliminate sidewall compaction and air pockets. That gives me the best advantage possible. That base prevents that spike from getting too deep in the seed trench. Overall, the Yetter Poly Twisters and corn have provided 5 bushels to the acre gain over the solid rubber closing wheels. The SI distributing finger till wheel you see at the end of the graph there, that provided 2.7 bushel, which is still a great gain. I am not going to recommend that closing wheel in a conventional scenario. They perform the best in no-till and cover crops. That's where I'm going to place those wheels. The other wheels on the screen, they can work pretty good in most conditions. Now when we transition to soybeans, very similar data set here. The Yetter Poly Twisters provided 2.5 bushels again. Again, that might not be the best wheel for you. However, we're seeing gains in corn and soybeans both. We start looking at acres to pay off. I always tend to pick on the bar that's in the very middle of the screen. It's the gray bar for a 16-row corn planter. The price of corn in that example is $5.50 per bushel. That takes 128 acres to pay off the Yetter Poly Twisters in corn. Fairly quick payoff. In soybeans, that's 120 acres for that 16-row planter. That's $12 a bushel beans. Again, not very many acres. So we're moved from soybeans, now we're gonna talk about closing wheels on a high-speed scenario. High speed, things change a little bit different. I need to think about that system a little bit more in depth. So I wanna pay more attention as I speed up. I wanna do checks, digging, get that spatula in there. Let's double check that. Let's make sure the pressure's right. As a whole, I think we're gonna need a little bit more pressure. We might have to crank that down one more notch to get it to where I need to be to do all the jobs the closing wheels have to do. So in our closing wheel high-speed research, we found the Yetter poly twister versus solid rubbers has given us about 5 bushel more at 7.5 miles an hour. Now at 10 miles an hour, the yield gap isn't quite as big. I think we need the weight of maybe a cast wheel. We take a cast versus the poly here, there's a big weight difference. I can utilize and take some of this unsprung weight and make it to my advantage of keeping that closing wheel system firmly placed to the soil. You'll see the yield data on the screen here at 10 miles an hour. We're looking at a little under 3 bushel to the acre gain versus solid rubber control. Now with both charts here, you'll see furrow force. So the furrow force is a fully automated system that's made and sold by Precision Planting. That system utilizes a load cell at the first stage, which is the stitch wheels, and then the second stage is the firming wheels. That load cell puts the pressure or reads the pressure based off of that second stage wheel. So the stitch wheels up front are going to lift and fracture that sidewall. The second stage wheels are going to firm that soil around the seed according to the conditions and the setting that you prescribe in the 2020 monitor. So as you plant through your planter pass and conditions change, it's going to change the pressure based off that load cell in the airbag. So that's how it works. At high speed, at 7.5 miles an hour, the Yetter poly twisters does beat the solid rubber closing wheel system and furrow force. At 10 miles an hour, the furrow force does win, provides just over 3 bushel per acre over the solid rubber control. Now, at normal speeds, we haven't seen the yield gains out of the furrow force system versus the solid rubbers compared to the Yetter poly twisters. The poly twisters leading the charge. The furrow force, you take it, for example, our trials are 300 to 500 feet in length. In that 300 to 500 feet planter pass, our conditions don't change that much. So there's no reason for a furrow force to make a pressure change as we make that pass. So we're not going to see big gains out of that system. So what we're doing for 2022 is we are going to have furrow force on farm trials to see if we get a larger gain out of that system versus the solid rubbers. That's our goal. So at 5 miles an hour, 2-year data, we've seen 2.6 bushel out of that furrow force system versus the control in corn, and then 0.7 bushel in soybeans. It's a fairly expensive system. If you have the harnessing and the backbones from Precision Planting, it's fairly economical to go furrow force if you so desire to go that route. We hope to have good yield data, better yield data coming out in the fall of 2022. Now we'll move on to row cleaners. Like I said earlier, row cleaners I think are a very important part of the planter. I think every planter should have row cleaners installed. Our jobs with the row cleaners are to move as much residue as possible without moving a lot of soil. The advantages are reduced hairpinning. Hairpinning is where I take residue and we shove it in with the disc openers and they get inside, pieces of residue gets inside the seed trench. That will pull moisture away from the seed and will slow down emergence or might inhibit emergence as a whole. The goal of the row cleaners is to move the residue, and then with the residue being gone, I create a smooth path for my gauge wheels to run. I open up the surface for heat and sunlight to penetrate the soil and warm that furrow up. It also gives me more consistent moisture inside that seed trench, which promotes better, quicker, and more uniform germination and emergence. We start talking about no-till cultures. Most scenarios paired with a row cleaner, I'm going to take that no-till coulter off. Manual versus floating versus air, I'm going to prefer air row cleaners over floating, just because the adjustability, when I encounter different conditions throughout my field, I can get more fine-tuned. We start looking at yield data. Here's what we've got on the screen. Floating row cleaners in corn versus no row cleaners. We're looking at about a 4 bushel gain at floating and a little more than that at 25 pounds of down pressure in our short replicated research trials. In soybeans, we do have PFR proven at the floating setting exactly at 1 bushel gain. For instance here, another gain of row, or a positive advantage of row cleaners. The picture you see on the screen is slug damage from Atlanta, Indiana row cleaner trials. This is the no row cleaners here. Floating row cleaners, the next slide, we'll see that feeding is less. When I have 25 pounds down, our feeding is almost gone entirely. So another case or scenario where we see a big gain from row cleaners. The Yetter 2967 row cleaner system is what we've got on our chart here for acres to pay off. We're looking at 800 acres to pay off for that 16 row planter at $12 a bushel soybeans. So it does take some acres. As you encounter different conditions on your farm, it's going to pay off much quicker than what you see here on the screen. What about Reveal? Reveal is a new row cleaner system made and sold by Precision Planting. That takes the row cleaner off of the row unit. So the best way I can explain this here is I've got that row cleaner and I've got it on my row unit. Here's my row cleaner here. If it encounters a big clod or a piece of residue, that row cleaner is going to move up. What happens is that clod that I missed is going to go right to my gauge wheels. If that gauge wheel, the planter unit, hits that clod, it's going to move up, which is attached to my row cleaner, and it's going to move up. It's a never-ending battle relationship here if my row cleaner is attached to the planter unit. So what we can do here is Reveal moves it up to the frame toolbar, and then if it misses residue and that row unit hits it, it doesn't affect the row cleaner. It's independent, which works pretty well. That system gets rid of the treader wheels that set the depth of a typical normal row cleaner setup. So it takes it off of the row unit and installs it on the planter frame. That also takes the chatter out of that row unit. We hope to test this high speed and normal speeds coming up to see if we can get a big advantage out of Reveal, and we can share that data with you. Disc openers. This is where we start talking about the STP disc opener. That disc opener is made and sold by Prescription Tillage Technology. It's right here. It's a serrated opener. It's 4.3 millimeter thick. One opener is a little bit less in diameter than the other opener when we pair them together, which means they are spinning at different speeds. As they spin at different speeds, they lift and fracture the sidewall and do a little bit of tillage in the trench. They also make a wider floor of that seed trench, which helps my closing wheels do a better job of closing the seed trench when I have that tillage, and then a wider floor, that seed easily gets to the bottom of the seed trench. The bearing is bolted on with Torx heads instead of riveted on, so as that opener wears out, I can keep the bearings and just change out the blades. So I have a little bit less expense there as those disc openers wear. We start looking at yield data, very consistent data, 3-year multi-location PFR proven data. We're looking at a little under 2 bushel gain in corn and then a little over 1 bushel in soybeans. So pretty good consistent gains out of the STP disc openers. I do recommend finding a dealer and getting these in your hands before you make an order. Don't order them this close to planting season. The chances of you getting them for 2022 is pretty slim. Acres to pay off. In corn, that 16-row corn planter, we're looking at 205 acres. Not very many acres to pay them off. In soybeans, 126 acres at $12 bushel soybeans. I'm going to pinpoint and recommend them in a no-till or cover crop scenario. They do work fairly well in conventional, but I see bigger gains out of the no-till scenarios. Seed firmers. What you see on the screen here is a planter going through the field. I've got my closing wheel tail removed. I've got a high-speed camera here. What I can see from the video is the soybean seed is perfectly spaced coming off of my seed tube. But the gap in between the end of that tube and the bottom of the trench is a fairly wide gap. So as the seed jumps that gap and hits the bottom of that trench, the seed spacing changes. So the singulation doesn't happen anymore. Also in the video, you'll see towards the end, the seed is starting to come out of the trench. A seed firmer is not going to fix the spacing problem, but it will prevent the seed from exiting the seed trench. So it's another positive part of a seed firmer, as well as getting that seed clear to the bottom of that seed trench. So I do recommend a seed firmer in most scenarios. If you're concerned about the seed spacing and the gap coming off of that seed tube to the bottom of that trench, a high-speed tube from any of the 3 manufacturers will solve that problem. This next chapter here, we're going to focus on starter fertilizer systems. We'll go fairly quick here. On our trials, our control is 30 units 2x2. So that's one side of the row placed 1.5 to 1.75 inches below soil surface. Our next treatment is 30 units, so same rate, 2x2x2, which means both sides of the row, same depth. That's the only difference. Same system. In that scenario, we gained 5.7 bushels over that control with our long-term data. So why is that? Why is it the case? You'll see in the picture here, the control, we're seeing preferential root growth. That was pretty common from where this picture came from. That was a 2020 growing season. Every plant we pulled from the control showed up that way. Once the corn roots find that nitrogen nutrient, they tend to put more roots in that direction. So if I'm applying my fertilizer on one side of the row, the roots get there, we put more roots there. When we're putting on both sides of the row, the roots have a better chance when they find those nutrients to have a better formed root structure. When I go from 30 units, same rate, and I double it to 60 units 2x2x2, I gain 7 bushel. So 1.3 bushel better than that 30 unit 2x2x2 treatment. I don't know if 1.3 bushel is enough bushels to double my rate of N. When I start to think about tending and fertilizer tanks and pumps and systems on my planter. So I want to run all of those scenarios through my head before I make those decisions. We roll on to systems here. Here are the systems that we have tested throughout our nitrogen 2x2x2 trials. The Yetter 2968s, they mount between the gauge wheels and closing wheels. It's the most economical option you see on the screen here. They have a high pressure injector or an optional knife to get that solution into the ground. When testing those, a few of the things that I've come across, I don't think in a scenario where I'm planting around a lot of curves or terraces, I might run into a scenario where I might apply the liquid solution on top of the seed. So that's the biggest worry I find with that system. Overall, it's a pretty good system. The Martin Dual UMOs mount on the front side of the planter row unit. We're still able to use row cleaners with that scenario. And no-till, I found instances where I had a hard time of keeping that row unit in the ground. So in that case, they do offer a serrated coulter, which will help with that system penetrating the soil surface and getting it into the ground. Overall, very hard, heavy, well-built system that worked well. The next system is Precision Plantings Conceal. It does not use a coulter. It utilizes a gauge wheel that has 2 halves. They have a knife that rides in between them 2 halves, and that gauge wheel holds the residue down so that knife can cut the residue and get through it. Overall, these 3 systems have performed almost identical to each other when we start looking at the yield data. So I recommend going with which system works best for your corn planter if you're interested about getting into starter or going from one side to both sides of the row unit. You'll see on the screen here, our 4-year multi-location data has provided a $22 gain with 30 units on both sides of the row versus one side. In 60 unit rate is the dark green bar. That's a $27 gain. So $5 a bushel better at 60 units versus a 30 both sides of the row. That's 372 corn. So we're much higher than that today. So these values would be inflated for today. I forgot to mention the trials. Each treatment has the final nitrogen rate is the same for all treatments. So we change the sidedress rate to account for the starter 2x2x2 different rates. So as we roll forward here, we also see there's a $27 per acre gain with the 60 unit rate. So that's twice the rate. I don't think that's enough money for me to tend that much more N or whatever solution I'm applying at planting time. So what about dribble? So as an agronomist, I would typically not recommend dribbling nitrogen out the back of a planter like what we have here. So this unit was supplied by RE Skillings in our testing. All we do is dribble it. We don't cover it up on the back side. We got a few treatments here. I do think, however, not as a recommendation, but if I'm a farmer looking to get into starter or planter applied nitrogen, I might start with that system because we're looking at around $100 a row versus $500 or upwards to $1,000 a row for some of those other systems. But if I buy that system with the intention of going to another system in the future as a goal, I'm okay going that route. That allows me to learn of how I can best tend and utilize a tank setup and pump setup on my planter and tractor to make that the easiest on my planting operation. Because at the end of the day, I'm trying to plant a crop, not apply fertilizer. Applying a fertilizer is just taking advantage of the trip. So in 2021, we do have some yield data from that dribble application versus conceal on both sides of the row. The dribble application also on both sides of the row, we lost $10 an acre, okay? But the conceal on both sides of the row gained $22 an acre over one side of the row, which means I did better, I did $12 an acre better with that dribble than I did on one side of the row. So there is an advantage to it, just not as much as getting it in the ground with conceal or Martin's or Yetter's systems. Now when we add a stabilizer, Factor Plus, which prevents volatilization, we lose $16 an acre. We did not capture enough bushels to pay for that nitrogen stabilizer. So we want to make sure we pay for that. In 2022, we are looking at other products to pair with that UAN application in a dribble scenario to recapture those bushels that could be lost by volatilization. So now we'll move on to the next chapter, which is Downforce. Downforce, I believe, is the most important component of the planter to help you keep a consistent depth. We've done some Downforce trials over the past couple years, is what you see on the screen here. I like to think of it as hydraulic versus air versus springs. If I have a spring row unit, I want to make sure that I'm doing my due diligence, that I'm checking and making sure the settings are right for the scenarios that I might encounter in the field. So I want to dig, like I said earlier in the Downforce and planter maintenance chapter, infield setup, go back to that chapter, and I go in depth on how to set your Downforce system. I want to do that for springs, air, and hydraulic. If I have a spring system and I think I want to go to a hydraulic, I'm going to skip air completely. We're going to bypass that system. I'm not going to put the investment there. We're going to go right to hydraulic because that is row-to-row control. That'll do a much better job and it's much faster than an air system. At the end of the day, trying to provide uniform planting depth row-to-row. We start talking about high speed. I think hydraulic downforce is an absolute must for high-speed planting. Automatic versus manual systems, we're going to see big gains for automatic systems versus manuals. So we start looking at our trials. I want to put that disclaimer back out there again that we have short 300 to 500 foot trials. In our control is Precision Planting's Deltaforce in an automated setting. Now that setting might be different from farm to farm, but the control is automated. Our treatments are 50 pounds manual, 125 pounds manual, and 250 manual. That's with the same cylinders. That's a static pressure. So we're not testing hydraulic downforce versus springs. That's the test I think you guys want to see. So stay tuned for 2022 data. We are going to have springs versus hydraulic downforce in a larger in-field scenario so we can give you better yield data to help you better make decisions on your farm. The hydraulic downforce system, regardless of who you choose, they are a fairly expensive system, and we want to make sure we give you all the pieces of the puzzle to make that decision easier. So when we're looking at our trials, that control is our highest yielding. Versus the 50, we're seeing a little over a 6 bushel gain for that. I tend to lean a little bit heavier when I set a corn planter up in the field. The 125 pound static pressure, we're not gaining quite as much. And then again, not quite as much with that 250 pound setting. We look in soybeans, again, PFR proven with that Precision Planting hydraulic downforce, Deltaforce system. Our automated is the best. The yield gains are minute. You just didn't have to make the changes in that 100 or 300 to 500 foot length on our trials. When it comes to acres to pay off and corn, we're looking at a little over 1,000 acres to pay off in that 550 corn scenario for a 16-row corn planter. In soybeans, we're looking at 1,500 acres to pay off that system at $12 soybeans 16-row corn planter. To pay that system off, that is if you already have the SRM-based harness and all the components for that Deltaforce system. This payoff is for the cylinders and the manifold and the hydraulic hoses and the load cells to make that system work. All right, in this next chapter, we're going to cover high-speed planting systems in depth. We've had a good opportunity to do some high-speed research in the past 3 years, and we're going to dive into this. So in 2014 is when the first 2 high-speed systems were introduced. That was the Precision Planting's Speed Tube system and John Deere's Exact Emerge system. From 2014 and on, here we go, we're going to speed right up. So here's the seed delivery system. In 2021, Beck's Hybrids and PFR had the unique opportunity to test all 3 systems that are on the marketplace today. Those systems, we're going to dive deep into each one of those. We'll start with Precision Planting Speed Tube. So the Precision Planting Speed Tube pairs with the VSET. The VSET meter, I think, set the standard for meter technology several years ago. It's the only system that can still be used with a regular seed tube. The finger wheels that you see at the top of the unit grab the seed off of the disc and then drive and transition that seed to the belt, and then the belt drives the seed down to the bottom of the seed trench. Therefore, we are in control of seed placement, and gravity is no longer in control. That system is a 12-volt system. We're going to have an alternator for 8-row planters and above. It pairs well with Deltaforce, their hydraulic downforce option for Precision Planting. The 2020 monitor, what the 2020 monitor has done for you as a farmer is amazing. I remember the first time my dad got that 2020 monitor, what it did was got him out of the tractor cab and realized he had problems that he never knew he had. It also, the 2020 monitor also made the industry get better on a more competitive level, and therefore we've got better technology because of Precision Planting and the 2020 over the past several years. Their system is a CAN bus system, looking at roughly $3,500 a row. For a 16-row planter, we're looking at $56,000. Each of these systems is expensive. It's like jumping off a cliff. There's a lot of money here to go high speed. We're going to talk about the advantages of doing so. John Deere's ExactEmerge system is next. That's the next system that we tested in 2021. Here's how their belt brush assembly mounts to their meter. So their meter sits in there at an angle. They have a bowl-shaped disc that drops the seed on that brush. There's no handoff mechanism, okay? So there's not a separate motor up here doing any work. Everything's paired together. It utilizes a brush instead of a cleated belt, which gives me infinite opportunities to drop a seed in that brush and then drive it to the bottom of the seed trench. As you can tell, their components are really, really big. Nice, robust system. It works really well. They have a tractor-powered generator, dual brushless motors, the brush belt, and then a bowl-shaped disc to get that seed off that disc onto the brush. It's very, very easy, simple transition. The biggest advantage of John Deere system is isobus. So plug and play. If I've already got a John Deere monitor and a John Deere system, I can hook onto that planter, plug it into my isobus terminal, and I'm off to the races. I don't have to have 2 monitors in the cab to make that system work. $4,900 a row retrofit. That is for the speed components and the downforce system only. If I have a pre-MaxEmerge 5 row unit, I'm going to have to upgrade my row units as well. So there will be another expense above that $4,900 a row. For a 16 row planter at $4,900 a row, for instance, if I have the MaxEmerge 5s, we're looking at around $78,000. That system here you can see is on this planter here. My bowl-shaped disc is right there. And there's everything for that meter. Nice, robust components to make that work. So the last system that we're going to talk about today is the Ag Leader SureSpeed system. Ag Leader contacted us in the fall of 2020 and said, hey, we want to do some high-speed testing with you guys with a new product that we're coming out with. Here's their system. You can see at the bottom of the housing right here, it says by Kinsey. So Ag Leader and Kinsey put their heads together to make this system. It's right here on this row unit. The Ag Leader system utilizes their own cylinders and their own harnessing. And they also have, their modules are different than Kinsey's. Those are the differences. All the hard mechanical components are identical from Ag Leader to Kinsey. Kinsey utilizes an Ethernet cable for their harnessing. So we start taking this unit apart, here's what we get. We look inside, so we're gonna open this thing up, and here's what we got in the inside. My disc on one side, that's the side the seed's gonna be on. On the inside, I got a knockout wheel and my electric motor gear turns that on the inside. And then I got a singulator right there that pops out nice and easy. It utilizes brushes instead of a steel component here to simulate the seed off that disc if I get doubles. So pretty simple components there on the inside of that meter. It did work pretty well. It was brand new, commercially available for the 2021 planting season. So we're going to talk about the Ag Leader version in depth here. The 24 volt system, where we need a generator instead of an alternator versus the precision planting system. They've got a really low seed exit, which I really, really like. If you can see here, we're looking at the bottom of the row unit, and you'll see the guard is actually below the backside of the openers, and then my speed tube is sitting right above that guard. That ensures I get the seed clear to the bottom of the seed trench. Supportive seed rail on the inside. It's really easy to take them tubes in and out. It utilizes an in-command 1200 monitor. Nice big monitor. It's got a lot of options as far as sensing goes for that system. And then Agfinity. Agfinity is a cloud-based software that's similar to Climate Field View, which allows me to go back to the field in season and check on my planting performance. $3,300 a row roughly for a complete system minus that display. 16 row planter will be roughly $52,800. We start looking at data. I'm gonna roll back into Downforce here a little bit. What you see on the screen is a high-speed trial. In the middle of that map, you'll see there's a circle that's missing planting data. That's a utility pole. Not long before planting season, the utility company wanted to replace that pole. You can see the downforce compaction leading up to that pole. This is the applied downforce map. So with the Ag Leader system, I've got a couple settings that I can set my automated downforce to. And this field, we set at the standard setting, which means we're targeting 100 pounds of gauge wheel load. So what that does is when we get in planting position, it's gonna pull on my load cell. We pull on that load cell. If I'm at 100 pounds, the system is going to say we're good. If I'm at 100 pounds or above 100 pounds or below 100 pounds, it's either going to supply more hydraulic pressure or less. So that's what this map is. We're at the applied downforce. That's the amount of pressure it took to keep that system at 100 pounds of gauge wheel load. So if I start to dive into this map here, the dark green is negative 260 pounds to negative 6 pounds of downforce. That's full lift, okay? Green, light green, is negative 6 to 27 pounds. 4.2 acres. The dark green, we had 4.8 acres. The yellow is 27 pounds to 70 pounds of applied downforce. I'm at 4.8 acres. The next is light red. I'm at 70 pounds to 137 pounds, 4.8 acres. The dark red, 137 to 406 pounds. Most of that is right around that utility pole. That's only 1.7 acres of this 22 acre field. This field was conventional tilled, chiseled in the fall, and worked right before I planted it. So it was fluffy ground. I did not expect to see this. For me, this is a big eye-opener, and it really shows the true advantages of hydraulic automated downforce. If I would have had a spring in this field, I guarantee I would have been wrong at least 25% of the field, if not 75% of the field. Because conditions changed. This field is mostly one soil type. I did not expect to see this. So it's a big eye-opener. As I roll into fall strip till, this is with a Case 5310 bar, not freshened in the spring. The high-speed map is on the left side of the screen. The darker the green, the faster I'm going. So if you follow those lines, you'll see there's red areas of the applied downforce map, which shows it took more downforce at the higher speeds. We start looking at the numbers on the next screen here. 5 miles an hour, I'm at 96 pounds of applied downforce. 7.5, I went up to 126. And then 10 miles an hour, I went up to 137 pounds of applied downforce. As I increase my speed, my downforce applied goes up. However, my gauge wheel load starts to taper off, which shows me my tractor and hydraulic system had a hard time keeping up at those higher speeds. Something that I need to think about going forward into 2022. We'll talk a little bit about that coming up. Another trial I intended to have was cultivated with the rows and then cultivated on a 5-degree angle. These next two fields coming up are the same soil type, and they are within a half mile of each other. Both worked on the same day in the fall and the spring. Both planted the same day, and both pattern tiled. The cultivated with the rows field, I had an applied average downforce of 59 pounds. When I go to cultivated on an angle, my applied downforce increased by 30 pounds just by having that ground worked at an angle. What the system demanded out of that system in a cultivated on an angle scenario versus cultivated straight, it took more downforce. It was demanding more because that row unit was starting to chatter more because it wasn't worked the way I was planting. So as I increase my speeds, I might think about working my ground with the way I'm going to plant my field. Unfortunately, I did not have any high-speed data with the cultivated on an angle because I couldn't pull it fast enough. I didn't have the horsepower. It just took that much more demand off my hydraulic system. You'll see a video here of the tractor going through the field, and you can see that planter kind of bob and weave as it goes through that field cultivated on an angle. Here we're trying to make a 10-mile-an-hour pass. At 5 miles an hour and 7.5 miles an hour, I did see a decrease of around a 1% of singulation out of the ground, not monitored data. So I start to look at some stand counts here. We'll look at each system. Precision plantings first, 5, 7.5, and 10 miles an hour. It looks like we increased our stands a little bit as we sped up. The ExactEmerge planted at 35,000 plants per acre. The Precision was at 33,000. ExactEmerge, flatline. Didn't matter on speed. The same amount of plants came up at every speed. The AgLeader SureSpeed system, pretty much the same as the ExactEmerge system. Flatline shows me that the system's working as advertised. Next, we'll look at singulation. This is singulation out of the ground, not monitored data. So we'll go backwards here. I'll start with the AgLeader. I started doing those trials first. And then typically I don't flag my stand counts, but some odd reason last year I did. I flagged over here and then walked 17 feet 5 inches and set another flag. This is a 6. The first trial I counted, it was a 6 replication trial, and I set flags across all reps. I counted all reps twice, all 8 rows. I had a lot of counts here. I did my counts. And when I got done, I went home that night and I slept, and I must have thought about doing stand counts all night long. Because the next morning, the first thing I did was I called my boss. I said, "Hey, Jason," I said, "I found some skips out here. Should I dig those skips? And if they're there, should I give credit to that system for planting that seed and getting it to the ground?" My answer was yes, and so his was too. So we started digging a lot of skips. Over all of my AgLeader trials, I counted 21,000 plants. 99 of those were doubles. Not very many when I start thinking about how many acres we counted here. And then total skips, 82. Those were seeds I did not find. So overall, total average singulation for the AgLeader system out of the ground was 98.9%. That's truly amazing. Across all my trials, fall strip till, spring conventional till, and then cultivated on an angle I hope was going to be in there, which was stale seed bed, and then cultivated straight. Amazing, amazing stuff. It worked as advertised. Same exact story with John Deere ExactEmerge. Worked as advertised. 10 miles an hour, 98.5% singulation out of the ground. Precision planting, I think we could have done a better job with the team that did those counts this year. It seemed to taper off at the higher speeds. The first 2 years we had high-speed testing with precision speed tube. We did not see that. So I think we should have spent a little bit more time counting those seeds with the speed tube system. We start looking at spacing. I did run firmers with the AgLeader trials. No change in spacing. What you see on the screen is truly amazing. Standard deviation values nice and tight. Look at yield data here. AgLeader at 7.5 miles an hour, we lost 0.3 bushels. 10 miles an hour, lost a half a bushel. John Deere ExactEmerge, I gained a half a bushel at 7.5. I lost nothing at 10. Precision planting speed tube, I gained 0.3 at 5 miles an hour when I compare the speed tube versus the seed tube at just 5 miles an hour. 7.5 miles an hour with the speed tube, I gained 0.9 versus 5 with the speed tube, and then 10 miles an hour, I lost a half a bushel. Okay, so a little bit of a loss there. So now we're going to dive in to how high-speed planting can help you make more money and be more profitable on your farm. So hang with me here. Existing equipment, 16-row planter at 5 miles an hour, we're going to plant 17 acres an hour. If I trade to a 24-row planter at 5 miles an hour, I'm going to plant 25.5 acres an hour. That's a 50% increase over that 16-row planter at 5 miles an hour. Now, if I take that 16-row planter and I install Precision Planting's speed tubes and just increase to 8 miles an hour, I'm going to plant more acres per hour than that 24-row planter at 5 miles an hour. That's an increase of 10% over that 24-row planter and 60% better than the 16-row planter at 5 miles an hour. I just still have to do a good job and make sure I do that. Now, how many days does it take to plant 4,000 acres? 19.6 days to plant 4,000 acres with a 16-row planter at 5 miles an hour. Now, if I increase just to 8 miles an hour, it is only going to take me 12.3 days to plant the same amount of acres. I gain a week. What's a week worth? We go back to 2019, a week is worth a lot. In 2019, we all know that was probably a rough year in our area. This example might exactly be what you encountered in 2019. This is Indiana USDA days suitable for field work. In April, we had 4.5 days available. May, we had 5. And then June, we had 11.5 days available suited for field work. So if we take that example, we move into our 17-year multi-location corn planting date study. These dates might not fit your local areas. So insert your dates into this data as an example. You probably know when you should be done planting corn on your farm. In this example from these locations, it looks like we need to be wrapped up planting corn by the end of May. We get into June, there's a high chance that we're not going to reach our utmost opportunity for all-out yield. So we want to try to target earlier planting if possible, and we can do that by high speed. In June, we stand to possibly lose 19% of yield. Of course, this is over the average. There will be outlier years where June might have been the best planting date. For soybeans, we're looking at a 20-year multi-location data set. Same thing goes. These dates might not fit your area. However, same story. We need to be wrapped up planting soybeans by the end of May. So we stand to lose 15% of yield in soybeans if we encounter planting in June. Now, these next examples, this is all theoretical. Taking that same 16-row corn planter at 5, 8, and 10 miles an hour, a 4,000-acre grower, 2,000 acres of corn, and 2,000 acres of soybeans, and we're working on 12-hour days. I know as farmers, we all work more than 12-hour days, but I had to stop somewhere so we could figure out this theoretical example. So that first planting, here we're utilizing the Indiana days suitable for field work from 2019. That first planting date, 916 acres is what we can cover with a 16-row planter at 5 miles an hour. The second planting date in corn still, we haven't finished our 2,000 acres up yet. We're going to plant 1,000 acres because we have a half a day more. The third planting, we're going to make our switch in June, okay? And we're going to have all of our soybeans planted at our least potential for highest yield. Now, if I speed up to 8 miles an hour, here's what we'll get. We'll make our crop transition in May and have a little under half of our soybeans to go yet in June. So we're taking earlier advantages in corn, getting some more acres planted in April, and then getting a good majority of our soybeans planted in May and then wrapping up in June. So just in corn, so the yield loss for high-speed planting, that half a bushel with the precision planting speed tubes, is figured into this calculation at 10 miles an hour. The price of corn for this example is $4.78 per bushel, and the price of soybeans is $11.95 per bushel. The corn-only advantage is $28,000, roughly, theoretically. That's not going to pay for a system in 1 year. However, if I focus on both crops, and it's roughly my farming example of 4,000 acres, we stand to add quite a bit of profitability to our farm. $146,000 in this theoretical example, we will pay for more than one system. We speed up to 10 miles an hour. We're going to make that crop transition in early May and plant almost all of our soybeans in May, and then have very little left to go in June. In this example, our advantage for corn is $34,000, but here's the biggest example is our biggest gain here is $235,000 for corn and soybeans. So is there an advantage to high-speed planting in your operation? I think it all depends on how much you farm and what you're trying to achieve goal-wise. If you're trying to target good conditions and get more acres planted and targeted planting dates, I do believe high-speed planting will work for you. Depending on which system you want, here's how I would make that decision. Through our testing, we have determined so far that each system that's on the marketplace today does perform as advertised. Now, how I would make that decision is if I have a good portion of a given system, harnesses, maybe the monitor of that system, I'm going to go that route. Or I can make the decision based on the relationships that I might have with the dealer I've been working with. So, for example, precision planting system, if I have a 2020 and an SRM-based harness and maybe even Downforce, it's very easy for me to go ahead and put those pieces to the puzzle and go the speed tube route. The same goes with John Deere or the Ag Leader system. Now, putting it all together, so I've been thinking pretty hard about the pieces of the puzzle it takes to do high-speed planting. And it's not just the planter itself. There's a lot of topics that we got to make sure that we think about before we pull that trigger on high-speed planting. We don't want to get caught in a situation where, hey, I should have traded tractors off, or I've got to spend more money elsewhere just to make this system work. So RTK guidance, I think you need some form of guidance. It doesn't have to be RTK, but your markers aren't going to hold up at 10 miles an hour or even 8 miles an hour for that matter. Horsepower. It is going to take more horsepower. So if your current tractor has plenty of horsepower for the planter you have at 5 miles an hour, you might be safe to keep that tractor. If not, I want you to run that through your head and help you make a decision if this is the route to go down. Hydraulic capacity, I struggled there as well as the horsepower. So this year we're going to a different tractor that we already had on our operation. And then I'm going to add a PTO pump to take the pressure off the tractor so I don't run that tractor short on hydraulic capacity. High capacity fertilizer systems, if you're currently doing starter fertilizer, liquid UAN, or some other form on your planter, I want you to think about going from 5 miles an hour to 10. Basically, you're doubling your rate. You're going to use the same amount of fertilizer in that field, but you're going to have to tender it faster. So be thoughtful of that. The high-speed delivery system, I do not recommend planting high speed without a speed tube delivery system of some sort. Proper maintenance, I want to make sure I keep on top of that maintenance. I think it's even more critical at higher speeds than it is at 5 miles an hour. Hydraulic downforce, we hope to have some trials in 2022 that will help answer this question better. But I think hydraulic, automated, row-to-row control, active downforce is going to be critical for high-speed planting. Aftermarket closing wheels, they make a huge difference, and they offer a lot of bushels as far as a yield gain for 5 miles an hour. The data earlier that we showed similar results, so we do recommend aftermarket closing wheels for high-speed planting. Adjustable row cleaners, I think we want the air adjust row cleaners in this scenario so you can better fine tune those for the various conditions at the different speeds you're going to be planting. Good field conditions, we can target those conditions today. We can wait for those conditions, not plant by the calendar, and we can no longer have to worry about planting in marginal conditions. Strong toolbar, we're going to have to keep a better eye on this and make sure we've got a toolbar that is suited well for high-speed planting. And then last but not least, durable row unit. We've kind of learned this by first-hand experience. John Deere Maximers 2, that would be the 7200 corn planters. They're not suitable for high-speed planting. We've actually ruined a few of those row units through our testing, and we've had to update that planter to Maximers 5 row units. Kinsey 2600 and earlier, Case IH 1250 and earlier, or White 8000 and earlier. I want to target a planter row unit that is made out of cast construction and is highly durable that can sustain the abuse from the high-speed planting system. Thanks for tuning in today and joining our planter clinic. I hope you've learned something and can help you be more profitable and do a better job of your planting pass in the 22 planting season and the future seasons. Thanks again.